Okay, everyone, welcome back to our statistics class notes here in section 9.2, where we're trying to make sure we understand and demonstrate the central limit theorem for sample means. Here on page 141 and 142, we're going to get into another example on home prices, example 161. So home prices in a certain community have a distribution that is skewed right, so it's not normal. The mean of the home prices is 498,000, so that's told to us as the population mean, so that's mu, with a standard deviation of 25,200, which is sigma, the population standard deviation. Now let's suppose we take a random sample of 30 homes in this community. So right off the top of my head, I see the number 30 for my sample size. I know that my sample size is large enough. What is the probability that the mean of this sample is between $500 and $510,000? So, checking the central limit theorem conditions, we have 1, a random and assumed independent sample. 2, we do have a large sample since it is greater than 25. Sample size is 30. And 3, we do have a large population since it's reasonable to assume that there are more than 10 times 300, our sample size, or 3,000. Ooh, that should be 10 times 30, sorry. 10 times 30, which is 300. There's more than 300 homes in the community. I don't know why I did 300 there. I apologize. Make sure you change your notes there. This is 10 times 30. So there should be only 300 right for this population. To check to make sure we have a big population, we need to assume that we have more than 300, not 3,000 homes in the community. Thus, according to the central limit theorem for sample means, we know the distribution of sample means is approximately normal, the mean of mu, and a standard deviation of the standard error, which the standard error is the population standard deviation sigma divided by the square root of n, the sample size. So the mean was 498,000, and then the samples, or the standard error is going to be 25,200 divided by the square root of 30, which is 4,600.87. So again, we can use our stack crunch normal calculator, because we know that we've satisfied the central limit theorem, making our distribution of sample means approximately normal. So we use our stack crunch normal calculator and look for the probability that x bar is in between 500,000 and 510,000, making sure you put in the proper mean, the population mean, and the standard deviation, which is the standard error. So you get about 0.33 or 3273 to 4 decimals. Now, suppose we take another random sample of 10 homes in this same community. Can we find the approximate probability that the mean of the sample is more than 510,000? So now we have a sample size of 10. Right away, that's a problem to us. That should perk our ears up because that's not larger than 25. So then we have to ask ourselves, well, was the original population itself normally distributed? And it was not. We were told it was skewed right. So because the population of home prices is skewed, not normal, we would need a sample size of at least 25 to apply the central limit theorem for sample means. So since the sample size is 10, we cannot find this probability.